All right, so polynomial functions and equations, lesson 5, factoring polynomial expressions, part 1. So we're going to work on factoring them. If their lead coefficient is 1, we'll see how it works later on. To start off with, this is like review of 20-1. This thing has x-intercepts of positive 3 and 2. The zeros would be, hey, positive 3 and 2. The roots of the equation, positive 3 and 2. Why we use 3 different words for really the same thing, I couldn't exactly tell you. But they are the roots of the equation, zeros of the function, and x-intercepts of the graph is all the same. So, turns out that if we were to factor this thing, we get these. What they want to see is that x equals -8 and x equals 3. Now what you notice is that the constant term is -24 and the zeros are -8 and positive 3, which, hey, what do you know? They multiply to that -24. So the zeros are factors of constant. So the factors of this polynomial would be this. And if you notice, the zeros are 2, 1, and -1. All of those things multiply together to make this, well, plus or minus. They aren't exactly the same, but they are basically the sum. And if you multiplied all these things together, you get them. So that they're kind of just the negatives of each other, but still factors of constant. Close enough. Okay, so this is this thing called factor theorem, or integral zero theorem, which states that the zeros in an integral polynomial function, that is, if all of your things are integers, are factors of the constant term. Hey, cool. So what we would do to factor something like this is we would first check all the zeros. The potential zeros of this thing are going to be plus minus 1, plus minus 2, plus minus 3, or plus minus 6. There's 8 potential zeros. That would make my factors x minus 1, x plus 1, x minus 2, x plus 2, blah, 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 x minus 6, x plus 6. My blah, blah, blah isn't all that much different than x minus 3, x plus 3, but yeah, whatever. So students are actually trying to find one of the factors. They did some work. Using factor theorem, we can put in the value and just see if it's a factor or not. P at -1 is 0, and therefore it must be a factor. And then we use this -1 synthetic division to solve it out. Nicole did basically the same thing, but just did synthetic division for each step. So if your remainder is not 0, well, then it just didn't count. It's not a function. As soon as your remainder is 0, it is a factor. So, like you're good to go with this. But you end up doing sort of more work here, I think, than this. I would prefer to do that rather than the synthetic division. Going back and forth, that's what it looks like. Finishing off the synthetic division, I would... So they've already done this. They found that x plus 1 came out. And your remaining thing is x squared minus x minus 6. Right? That's the reconstituted version of this. Now this thing, I can just factor because it's a quadratic just in my head. Two things that multiply to -6 add to -1. So x minus 3, x plus 2, bada bing, bada boom. Okay. Apparently I should have checked to see if I'd erased all this first. Let's see, where's my page sorter? Right, no, this one. Okay, apparently there's nothing else I need to erase, so that's a good sign. List the potential zeros. They're going to be plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. So lots of factors for me to potentially check. I wish that I could just pray and be given the solution, but I will wait for a little while before we hit divine inspiration. I can see that there are some similarities here. What's this going to be? Negative. Is 1 work? Usually 1 or negative 1 will work. So 1, 2, that's 3, negative 7 is negative 4, negative 4 minus 8, negative 12 plus 12. That works. So positive 1 works. So P at 1 equals 0. Good, yes? So now what I'm going to do is just do this. So I'm going to factor that out. So 1. This is 1, 2, negative 7, 8, and 12. I'm not missing anything. 4, 3, 2, 1, 0. I've got all my degrees accounted for here. So now I just rock through my synthetic division. 1, 1, 3, 3, negative 4, negative 4. I swear that worked. 1 plus 2 is 3, negative 4, negative 8, 12. Okay, so I've made some mistake here. I don't see what it is yet, though. 1, 1, 2, 3, negative 7 plus 3 is negative 4. What? It didn't work. 1 plus 2, 3, minus 7 is negative 4, minus 8. It's negative 12. Negative 12 plus 12 is 0. Oh, negative 8. All right, back to work here. This is going to be negative 12. Negative 12. 12 plus negative 12 is 0. Whew, that was close. Okay, so now I know that an x minus 1 came out. My remaining thing would be x cubed plus 3x squared minus 4x minus 12. Now I got to find another 0 of this thing. So I go back to my drawing board, pick another one. I'm thinking maybe 2. Feeling like 2 might just do it. 2 cubed is 8. 2 squared is 4. 3 times 2 does. So it's x minus 2. P at 2 is also 0. Now, the nice thing is, since I just did this in that division, I even got my coefficients right over here. Let's put in 2. Come on in. 2 times 1 is 2. 5, 10, negative 6, positive 6. Negative 4 plus 10 is positive 6. 2 times positive 6 is positive 12. 0 again. I'm on a roll. Back to this factoring. Sorry, I had to pause you for a second. You probably didn't even know you were paused for like the last 10 minutes, but you were. Anyhow, I'm now down to a quadratic. If I really wanted to, I could synthetically divide this out as well. I would rather, at this point, just kick it into a quadratic and go based on my fantastic factoring skills that I acquired back in 20-1. 2 things multiply to 6, add to 5, x plus 2, x plus 3. So my final product is, drum roll, please. This is for you folks at home. So the actual roots, well, the actual factored version is going to be x minus 1, x minus 2, x plus 2, x plus 3. That's the whole thing. Now, if I wanted the roots of the equation, my solutions are just going to be x equals 1, 2, negative 2, and negative 3. Voila. So that's what we do. Try those out. On this, we have to match the zeros to the graphing calculator. it turns out there's going to be one nice one and then some not nice ones. So let's do this out. You know what? I want to do it on the Inspire instead. It doesn't. You guys all know how to do this with whatever calculator you've got anyway. But I'm going to go to here. X cubed. Boy. X cubed minus 3x squared minus 3x plus 1. There it is. Menu, analyze graph, enter 0. So that one is at -1. That whole thing, just throw it over there. Menu, analyze graph, 0. That is this one. Whoop. Anyway, move that out of the way. That's fine too. And then my last one. Now those are a little hassle. They're like all over the place. But there's my zeros. Now the -1 I know is good. So I know that p at -1 equals 0. So what I'm going to do is I'm going to take that one out first. Thank you, calculator. You've done your job. So synthetic division, 1, -3, -3, 1, -1, 1, -1, -4, 4, 1, -1, 0. So this thing is going to be x plus 1, because it's the -1, 0, and then times x squared minus 4x plus 1. And now, I know that they're not nice, but I can still do this using my quadratic E formula. So -b plus minus b squared minus 4 times a times c all over 2a. So that's 4 plus minus root 12 over 2. 12 is 2 times 2 times 3, so 2 would make the escape. 1 gets out. So 4 plus minus 2 root 3 all over 2 equals 2 plus minus root 3 as my other solutions. Then if I were to do this, I know I'm trying to get that number. Store that as, well, let's call it a. So now if I go over to here, a value is at 0.2 blah, 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 2 minus square root 3. Hit enter. Get the approximate form. Oh, look, my approximate forms match. Bada bing, bada boom. So that's really the only way I can force you to do this rather than the graphing stuff that we're going to see down the road. But I can do that. So that's the thing. Anyway, so enjoy that lesson. If you have questions, come in and ask.